Now let us see more detail. A dot info. See, more information we can get. We can get. See, like uh, the A, that means the data frame. It's a data frame. See, data frame, Pandas data frame. 21613 entries, 0 to 21612, total 21 columns. And we have here different columns, 21 columns: ID, date, price, up to 20. That is total 21. Square feet, lot 15. Okay. So these are different columns. We have 21 columns. And see, non-null values. Next column shows the non-null values. So that means the data set we have inputted, the first column, that means the ID, column name ID, contains 21613 non-null values. That means how many total entries are there? 21613. Now out of 21613 entries, all the 21613 are non-null. That means all the all the cells under this particular column, all the elements are filled with some values. They are non-null values. In some of the cases, some of the cells may contain null value. Okay, so that null value is very important because if you come across that null value, it will impact the entire analysis. Okay, so in order to know any null values are present, we can use this info. This is not actually to see the null values only. We have multiple uses with this info. So that means we can see how many number of columns are there. A total data set contains how many rows we can see, and see how many non-null values are there, and we can see type of each column. This column ID contains integer data type. This date contains object data type. So like that. This is float, then integer. Okay, so this information you can get using this info method, data frame dot info. Here data frame is in A, so that means A dot info will give you information, detailed information. You can try this A dot info. Why? Because we need to know any null values are present in a column. That should be known in advance before we proceed with the data science operations or machine learning operations. If there are any null values, we have to do some manipulations. We have to uh, somehow you have to fill that column, fill that cell. We have to give some dummy or some what to say in case of age. If the column name is age and it contains values which are ages of different people, and assume that one particular value is missing, it is null. Now you can easily have an average of the ages, and you can fill that empty column as the average of all the ages in that particular column. So like that, you can fill that value. We can fill that column, that cell with the average value of the all the ages, all the data in that particular column. So like that, you can have some filling methods. So we will study how to fill empty columns, empty cells. Okay, so this column contains these many entries, and all the entries, the total how many entries are there? 21613 entries. Out of this 21613 entries, all the entries are non-null. So there is no need to uh, do any operations on that. We can use this data set straight away because no null values are present. Okay, usually we'll be having some null values, and we need to operate on that null values. We have to rectify that issue. That we will see later how to fill null values. Then one more method, a dot describe, and this will give you the statistical information, detailed information regarding the data set. See, it will also give the count. See, 2163 somewhat into 10 power 04. That means 21613. 21613. These many 21613. Okay, these many values are present in a column. Okay, so that information is given. Then see, this is the first column ID. Now, what is the main value of the values in that first column? Now, usually this ID column contains some identifier, and there is no need to calculate the mean. Okay, that is okay, but it will give you the mean value or mean value of all the columns. That's all. Now, price. We have some price column and the mean value of price column. Bedrooms we have, in that we have some entries. What is the mean value of that column? So like that, it will give you the mean value of all the 21 columns. Now it will give standard deviation. It will give the minimum value in that particular column. It will give the maximum value in that particular column. Now it will give you the 25 percentile, not percentage, it is percentile. You might be knowing what is the difference between percentage and percentile. Okay, it is the 25 percentile. This is 50 percentile. That means again the mean value. 50 percentile means the mean value itself. And this is the uh, 75 percentile. 50 percentile means it is this value is not the main. I will tell you what is percentile later. We will calculate the percentile towards the last. I will tell you what is that percentile. Okay, actually this 25 percentile means 25 percentile value is this one. So that means 25 percentage of the data is below this value. That is the meaning of this 2 point something. 25 percentage of the total value present in that particular column are below this 2.123049. Similarly, 50 percentile means you are getting some value here. 50 percentage of the data are below this 3.90 something. Similarly, 75 percentile we are getting some value. 75 percentage of the data are below that 7.30890 something. Similarly, for all the columns, the same thing. We will see percentile later. Okay, so these information are very important. Statistical information are very important as far as a data scientist is concerned. So we will see what is the importance of these parameters later. Okay. Now, apart from this, so this is actually a single code, single method to find all the statistical value. Apart from this, you can have a standalone. See, you want to find out the mean value of this particular price column. Say, you want to find out the mean value of this price column. You can have this method. A is the data frame. Then A of price dot mean will give you the mean value of price column. You can see it here. What is the mean value of price column? See, mean value of price column is 5.400 something into 10 power 5. The same value you are getting here, 54008, the exact value. You can verify it. Okay, both are correct. 5.4008 something into 10 power 5. Same value you are getting here. Okay, similarly, the second one, median. Median is not shown here. Okay, anyway, median, if you want, you can obtain like this. A dot price dot median. If you want standard deviation, STD. If you want the minimum value, if you want the maximum value, so you have methods here available. Okay, I think this is clear. We will be using this a.info and a.describe throughout this course. Regarding this percentiles, if you want, I can clarify that too. Anyway, I have something for you at the last. I will show you the percentile. Not here, in the next. Okay, next notebook. I have saved some values. I have obtained the percentiles for some values. I will show you there. Okay, this count, if you want, you can get a dot count will give you non-null records under each column. Okay, altogether you can get almost the same information using this single a dot describe. Will give you entire thing, mean, standard deviation, count, minimum, maximum, everything. For percentile, you can calculate percentile too. That I will show you later. Because we have one plot, box plot, in our next uh, topic. So at that time, that box plot will give you this minimum 25 percentage, 50 percentile, sorry, 25 percentile, 50 percentile, 75 percentile, and maximum. There is a plot named box plot. Now at that time, I will be telling you what is that percentile more clear, because this is very much important. Minimum 25 percentile, 50 percentile, 75 percentile is important maximum. So that is the reason why we are use this describe here. We are studying this describe here. Okay, next we have discussed the mean, median, standard deviation, minimum, maximum. Then a dot shape. Shape, will give you number of rows, number of columns. That's it. Now, if you want to have value counts, now under bedrooms, how many values are there and how many times those values has been repeated. See, under bedroom column, you can see directly here. Under bedroom column, see, we have some three, we have some four, then two, then three, again two. This two has been repeated two times. Now, this is for the last five. So if you are taking the entire data set, how many times this two has been repeated? You want to know. If you want to know that, you can use this value count. Under bedroom, if you use value counts, see, you can see two has been repeated these many times. Similarly, three, four, five different entries repeated how many times? That will be shown here in this particular output. 3 repeated 9, 8, 2, 4 times. 4 repeated 6, 8, 8 2 times. So like that. Okay, so this is the use of value counts. And we should do all these steps when we proceed with the data science and machine learning. If you know these things now, then in my opinion, you will there won't be any issue for you to proceed with the machine learning and data science. Okay, and don't worry if you don't know, or if you are what to say, not comfortable with these methods. We will, when we study the data science, uh, at that time you will need to use these things. Then at that time you can come back and refer this and study in that time. Okay, no issue. Anyway, then data manipulation we can use. We can do data manipulation using pandas. How we will do some net data manipulations? Okay, and what is data manipulation? To make the data sets more readable and organized. Okay, that is what we are doing in data manipulation. More readable and organized. Okay, so let us see what are the different operations, manipulation operations. First of all, indexing, filtering. Now, for that, as I told you, lock and ilock. Lock and ilock are the two methods. Lock and ilock. So we have seen the same thing in data frame and series. Okay, same thing. Lock and ilock. Lock means, see, here is the syntax actually. Lock, row, column, starting row, ending row, starting column, ending column. Similar to the list we have seen. Similar to the data frame we have seen. NumPy also almost similar operation. Okay, starting row, ending row, starting column, ending column. You have to give. Okay, in between you have a column. This column indicates two, starting to ending. Okay, now if I give like this, a dot log, what you will get all the rows and all the columns. Okay, so this we have already seen. Now, if we want to particularly filter out or take price to bedroom. So price means where price is. See, price is this column, bedroom is this column. I want to, or price to bathroom you can give. Let me change this to price to bathroom. Price to bathrooms. Now let us see what is the output. See here, row, all rows, because no starting point, no ending point has been given. So it will print all the rows. Now what about columns? Only the price column, two bathroom columns, bathrooms column. Now see what is the output. All the rows, see all the 2161 columns. That means up to 21612. That means 21613 columns. And see what are the rows. 21613 rows, and only three columns we are getting. See, let us see what are the three columns. Price to bathroom. See, you can see price to bathroom means it will include both price and bathroom. It will include both price and bathroom. So that is a specialty here. Specialty of lock. It will include both starting and ending. Okay, so this is a specialty of lock. See, price is there, bathrooms is there. In between, how many columns are there? Only one column, bedroom. So that is why it is showing only one column. Okay, so this point should be clear to you. So when you filter or when you locate uh, columns using this lock, this is the case. This is the difference. Both starting and ending points will be included. Both starting and ending columns will be included. Price, bedroom, and bathrooms. Okay. Now, see again. See here, uh, rows 100 to 105, columns price to bedrooms. Let us see the output. Similar to the previous case, see, columns are price to bedrooms. Both the things will be included. Price and bedrooms. In between price and bedroom, any other columns are there? No. In between price and bedroom, there are no other columns. So only price bedrooms will get printed. Now let us see here, only price and bedroom. Now let us see the row starting from 100, ending at 105. So that 105 will also be included. Okay, so this is a speciality with this lock. Both the starting specified starting point and ending point will be included. Even if you use the index, even if you use the index, the operation remains same. Both the starting and ending index will be present. And this is the case with lock. Now, one more. This is same actually. No need to do it again. Okay. Then indexing by position. That is by using iLock. Now here, when it comes to iLock, as I told you, we are not using the names. See, like this price and bedrooms. We are using the index only. Okay. So here everything is index. Okay. See here, you can see this 100 is actually the raw label. That is why the 100 to 105 has been taken. Okay. Even if it is the index, but they are taking as the label. Both are same actually. Now see here, what is happening here? See, it is I am using iLook here. Starting 100, ending 106, starting 2, ending 4. See, it is similar to what we have already studied before. See, 100 to 106 means 100 to 105 only. It will not include 106. Okay, so this is quite similar to what we have studied in the uh, list, what we have studied in NumPy series also. Okay, when we use iLog, then this is the operation takes place. Starting from 100, ends at 105, not at 106. Similarly, 2 to 4 means there also the index position will be taken. Index will be taken. See, which is the second index, ID is the zeroth index, date is the first index, price is the second index. So it will start to uh, print from the price column. See, price column will get printed first. Now 2 to 4, sorry, not this one, this one, price column will get printed. Now 2 to 4 means 2 and 3 only, 4 will not be counted, printed. Okay, 2 to 3 only. Now which is the third one? Price, after that price, bedrooms. So price and bedrooms only will get printed. See, price and bedrooms. Fourth will not get printed. Okay, I think this is clear. Try to know the difference between the usage of lock and iLock. Lock means, this is the only difference. Lock means starting and ending specified values The starting and ending rows will get printed. Similarly, the starting and ending columns will be printed, including starting and ending. But in the case of ilog, ending minus 1 will be included. Ending will not be included. See, if it is given 106, then 105 will be included. 106 will not be included. Like that. In case of a column also, since 4 is given, 4 minus 1 is 3. So 2 to 3 will get printed, columns. Usually we'll be using iLoc only. So there won't be any confusion in future. But this loc, if you want to use, you can use. Now, there are some situations in which we may not be knowing the index position, index location. Now, at that time, you can easily use this loc. For example, in this case itself, if I want to filter out this column, this long, how can I use? Is it beneficial to use loc or iloc there? Now, in order to use iloc, I should count which index this long will come. That means I should count from the starting. So ID is the zeroth index, date is the first index. So like that, I should count from zero to this column, whatever be the column. You should count from that point, initial point to this column. That is time consuming and it is very difficult also. If there are 100 number of columns, if you want to filter out a single column, you should start from 0 to 100 in between. If the column is in between, that is tedious. It's a tedious job actually. So in that case, if you know the label of or the name of the column, you can easily filter out that using this lock by giving the column names. In that case only we can use this lock. Otherwise, you please go for this iLock. That is my advice. Then in that case, you try to know the difference. If you are including these names, the columns corresponds to those names will be printed. Similarly, if you are including this index, the rows corresponds to all these will be printed. 100 to 105 will be printed. Okay, so I think that is clear. Any doubt here? Now this is another example. Okay, that means 100 to 106, and the column is second column. Which is second column? Second column. That means second indexed column. As ID is zeroth indexed, date is first indexed, price is the second indexed. Now it will show the row number 100 to uh, 105, the price values. Okay. Now one operation, if you want to set all the values under bathrooms column to a value, say 1. If you want to set all the values under bathroom column to 1, you can do by using this particular method. See, a of bathrooms, that means the column we have selected, which we assign as 1, or you can assign as 2, no issue. Whichever value you want, you can use. Now see, under bathroom, what are the values present? Under bathrooms, see, you have 3, 3, 2. So different values are there. If you want to set all these values to 1 or 2 or 3, whatever it may be, you can do it by using this method. See, if I am using 1 and I am printing that a, see the output. See, all the values under bathroom. See, all are 1. Okay, similarly I can set 2. See, all the bathroom values are 2. Okay, so this is setting a single value to all the column elements. Now, if you want to apply some function to these column values, you can do it. Now, assume that you want to apply this function, this lambda function. This is actually, that means multiply each of the element in that particular. For example, you want to multiply all the elements in bathrooms column with 2. We want to multiply all the values in bathroom column with a 2, with 2, or some other values you can use, no issue. I am using 2 only. I want to multiply all the values with 2. Now for that purpose I can define a function. So this is a lambda function, so we have already discussed. And if you don't want lambda, you can use any other function, no issue. I am using this lambda function here. So that function I am defining as f is equal to lambda of x. X will be x into 2, that's all. X means the values. Value will be value into 2. So this is the function I am applying. Now how we will apply this function to the required column? Now, for that purpose, you select that column A bathrooms is equal to A bathrooms dot apply the function. That's all. This function will get applied to all the values. Now see the output. See, previously all the values we have set to 2. Now those values become 4 here. See, those values becomes 4 here because we have multiplied all the values under bathrooms with the 2 using this lambda function, just by using this apply function. So these are data manipulation steps. Sometimes we may require this. Okay, just know this particular step. You can apply, you can select a particular column which is equal to that column into application of the function. Function can be anything. That's up to you. You can define a lambda function or some other function. You give that function name here, that's all. My function name is f, so I used it here. Okay. Now, sorting. Sorting of values in columns. Now see here, a dot sort to values. See, sort to values is used. This is the code. This is the method used to sort the values. Okay. So a dot sort to values by which column? Which column you want to sort? For example, I want to sort the values in bedrooms. Sorting, ordering, ascending order, descending order. Okay, so that sorting you want to do. No, by means by which column you want to sort. That's so a dot to sort values by is equal to bedrooms. So this I am taking into a new object, new data frame. I am creating a new data frame B. Okay, now let us see the output. See which column we have sorted? Bedroom column. Bedroom column, you see a bedroom column starting from 0 up to 33. Okay, so it is sorted in ascending order. So by default, if you are not giving here something here, it will sort the values in ascending order. Now, if you want to do the sorting in descending order, this is the way. So you make that ascending will be always true. This is by default. Ascending will be true. So no need to give this. So if you want descending, you make it as false. That's all. If you make ascending is equal to false, it will sort the given column in descending order. See, 33, starting from 33, 11, 10, come down to the minimum value, which is 0 here. So like this, you can sort different columns by just by giving that column name here. Okay. Now, again, I have this one. We have uh, the sorting we have done on the data set we have imported. Now, I will give you one more example by creating my own data frame. See, like this. So, this is a data frame I have created. Now, if you have any data frame like that, you use the same thing. df dot data sort values by age. Age means this one, this column, age column. Sorting by age column, ascending is equal to true. What will be the output? See, age column actually values, age values are 25, 30, 45, 22. It's not in an order. So here I made it ascending. Okay, 22, 25, 30, 35. Ascending is equal to true is not required actually. This is by default, it is true. But anyway, I have given here that so. If you want to have descending order, you give false. F should be capital. That's so. See, descending 45, 35, 30, 25, 22. Okay, now why I have defined this new data set means because this is a huge data set, so it will be very difficult for you to view all the data inside this data set. So that is why, for simplicity, I have defined a new data set. That's all. Because we want to have some more operations, so it will be very easy if you define a new data set. Because every operation cannot be done on a single data set. Because I want to fill some empty cells. But in this case, all the cells are non-null, so I cannot have any empty cell in this. So if I want to show you how to fill the empty cell, then surely I cannot do with this particular data set because all the cells are filled here. So for that purpose, I have created a new data set in order to show you how to fill the uh, an empty column, empty data, empty cell actually. Okay, then filtering operation. Okay, based on some condition you want to filter the data set. For example, this is the data set we have. This is a data frame we have. Now I should get only the records which are having age greater than some 24 and the salary less than some 60,000. Say some typical values. That's some example values. I want to filter all the records in which age should be greater than 24 and salary should be less than 60,000. Now this and symbol is used for ANDing operation. Now this one I have defined as a filter 1 or simply filter. Now I am creating a new data set, the new data frame filtered df is equal to the actual data frame is there in df. See, uh, we already defined the data frame in df. Okay, actual data frame is there in df. Into that df, we need to apply the filter. So df of filter. Okay, df of filter 1. Now let us see what is the output. See? Only those values, only those records which are having age greater than 24 and the salary less than 60,000 are getting printed here. See, age is 25, age is 45, salary is less than 60,000. See, 50,000, 20,000. See, all other values. See, you can see this is 70, which is greater than 60. This is 80, which is greater than 60. But when you consider this condition too, you will get only two records. These two records. You can verify. If you have only one condition, then only one condition is enough. This and is not required. And is not required. That's you define the filter accordingly. That's I will show you how to do that. This is filtering operation based on some conditions. Next, just only one condition. Filter 2 is equal to df of the column name is salary greater than 60,000. This is the only condition to be satisfied. So here, see, here there were two conditions: df of age greater than 24 and df of salary less than 60,000. We had two conditions here, but here only one condition: df of salary greater than 60,000. Now we are defining the filter like this, and we are going to apply the filter. That's it. See, only condition is salary should be greater than 60,000. Only two records. See, you can see here. So here, when you see the record, you can see that only there are two entries, 70,000 and 80,000, which are greater than 60,000. See, 70,000 and 80,000. Now, this is the way to apply filters to data frames. I think this is clear. Any doubt you can ask me. Okay. Now I have shown you a method to see the null values. See here by using the info where it is. Yes, here. By using this info method, you can see how many null values are there in each column. There is one more method. If you want to know the null values, see here. This is another method. See, it will list. See this type of you can obtain by using this a not is null. That means, see, this is false. That means this is not null. See, wherever you have null values, it will give you true. Wherever you have null values, wherever the data set contains null value, it will give true. Otherwise, it will give false. That is the meaning of is null. Any null values are present or not. It's like a question. Here it is false because it is not a null value. So like that you can, if you want a view like this, you can use this is null. But in my opinion, and okay, so this is not very difficult to view. Where is the null value from this? So you can have this dot sum. Will give the sum of, see, like this, sum of null values in each column. See here, no null values, no null values. Sum means correspond all the null values will be summed together and will be printed here. Okay, we will see the application of this later. We have the application of all these methods. Mostly this is null we will be using, info we will be using, describe we will be using. At that time, you will be able to memorize these methods, or you will be able to understand why this particular method is required more clearly. Then, data cleaning. See, all these are data manipulations and data cleaning methods. So that means these are essential steps for data science. You should know these steps. Now, what is data cleaning? Removing unwanted or inaccurate records from a data set. Removing unwanted or inaccurate records from a data set. Okay. Now, some of the cleaning methods or some of the modifications we can do on the data. Changing the column type. Okay. So, actually, we can see. Let us take the data frame A here once again, A dot head, or let us see the A dot info. See, all the data types are shown here. Now, if I want to change data type of any of the column, I can do it. See, just by using this, changing the column type, changing the column data type. Okay, so for example, bedrooms columns, what is the data type? Under bedroom columns, what is the data type? See, bedrooms is integer. Bedrooms is integer type. Now, if you want to change this data type to some floating point, see, you can do it by using this. A dot bedrooms is equal to A dot bedrooms of, that means this is the column. A dot bedrooms is the column. Dot ask type float. This will be moved to A dot bedrooms. Now see the output and see the info. See that bedrooms column. See data type is changed to float. Initially it was bedrooms column. It was integer. Now the data type of that bedrooms column has been changed to floating point. So like this, if you want, you can change the data type. There are some restrictions because we cannot change the character to integer. That is not possible. Integer floating point is okay. Okay. So this is one operation. Now this is the one I wanted to explain how to drop a column. Dropping means how to delete a column. Okay. So you know that A is a data frame. Now I want to drop two columns or single column. You can drop. Now just by using a single column, I am going to drop this column named view. See, we have a column here named view. Where this one? This column I want to remove. Example. Now for simplicity, let me print that data set here once again. A dot head. See, I have that view column here. View. See, this is the view column. This one, view column. I want to delete this view column. Now this is the method. A dot drop of columns is equal to what is the column? View. I want to delete only view column. Now let us see the output. That view column was after waterfront column. Now let us see whether that view column is present after waterfront column. Here I am only seeing the first five values. View not found. Okay, view has been already deleted. So the what happened here is before this I have already deleted view. Again I am deleting this means this is not possible because view has already deleted. Okay, so this one I am doing as a separate step. View has been already deleted. So no need to delete it again. Okay, so I will show you the output here. See, I am viewing the first five only. See, what after waterfront? See, after waterfront, there is no column named view. So before this, we had that view column after waterfront. Now that view column has been deleted here. Okay, if you are trying to do this again, it will show error because I already received the error notification because this view column has already we have deleted. If you want to delete it again, it will not work. It will show you, it will throw you error. That's what happened here. See, when I tried to execute that line again, it raised the error. See, view not found in axis. Okay, view not found. Okay, now that is over. So this is the way to delete a column. Now, if you want to delete one more column, you can of course do. That means if you want to delete multiple columns, you can do. No issue. Just by giving view, then if I am giving one more, it will delete that column too. Anyway, I am not executing it because it will throw an error because this view we have already deleted, dropped. But if you want to drop multiple columns, this is the way. A single column, a single quote or double quote, no issue. You can specify the column name here, whatever the column name is. Okay. Now, this a dot info, this is just to show that view column deleted. See, there is no view column here. See, only we have 20 columns. Initially, we had 21 columns. Now we have only 20 columns, 0 to 90. Then, how to fill a null value? How to fill a null value? Now, for that purpose, I am creating a new data set here. So, this is the data set I have created. See, this value I have defined as a null value, NaN. This is very important. NaN means it's a null value. NaN means a null value. Usually in data frames, a data set, the null value will be indicated by NaN in data frame. Okay. Now, since it is difficult to uh, okay, so it is difficult to keep it null. I have just included this NaN here. Okay, don't worry. When we see different data sets, you will come to know what is this NaN. So Here, for the purpose of defining an NAN, I have used this np.nan here. So don't worry about these things. We will come to know. You will be given with the data set. So that data set will contain some NAN values. Then your duty will be to remove this NAN. Don't worry about this. How to define this NAN and all. Here I cannot keep it null. See like this. So if I do like this, what will happen? This will throw an error because here we have one, two, three, four, five values. Here there are only four values. So there will be an issue, four and five. So in order to avoid that, empty should be specified like nan. Okay, don't worry, we will come to know about this nan later. And, anyway, you will be given with a data set which contains some nan values. So don't worry. Now your duty will be how to remove this nan value or empty value. Now this is the way. Fill NA. Fill NA. Now how to fill? See, this value is empty. How to fill that empty value? This is this can be done by using, this can be filled by using a code, a method, fill NA. Now which is the column that contains this this nan value? Salary. So df dot salary is equal to df 5, df5 actually, df5 dot salary is equal to df5 dot salary dot fill NA with what value you have to fill. With what value you have to fill, that you have to give it here. Now, simply if I want to fill it with 5, you can give 5 here. Not an issue. See, that value will be filled with 5. Now, if we want to fill that empty value with the main value of the salary, you can do that too. Like this. df5 dot salary dot mean. That means this will find out the mean value of the salary column. So we have some value 50,000, 80,000, 30,000, 70,000. So the mean value of that, those values will be obtained, and these values will be inputted here, and that value will be filled here. So let us see. Uh, Something happened, so let me clear this again. Now see, it has obtained the mean value of the values present under the salary column, and it has filled the empty location with that mean value. Now if you find the mean value of these values, you will get this 57500. Now that value will be filled in this particular location. Initially this location we had null value na. Okay, that value has been replaced by the mean of all other values under this salary column. I think this is clear to you. You have to do this in your data science operation, machine learning. So at that time, you will come to know, or you will get familiarized with all these methods. Okay, any doubt up to this? So fill NA is the method to fill empty values. Empty values will be NaN. Now, wherever you have NaN under this salary, wherever you have NaN, those locations will be replaced by the uh, mean value of the salary column. That's all. Now here we have only one location, so there that replacement has been taken place. Now if you had two NNs here, the two locations will be replaced. That's so like that. Wherever you have NN values under this salary column, a replacement will take place. Now, if instead of this mean value, if you want to uh, give our own value, some 5 or 6 or something, that is also possible. I have explained already. That's all about pandas.